In this problem, we have a fork support with a force being applied at point C there, and it has the vector components of 50I, 40J, and minus 80K newtons. It is supported by a cable running from C to D. It has a joint at A, okay, and that particular joint will only support forces or resist forces in the Y and Z, and no moments about there are developed. And at B, we will also only have reactionary forces in the X, Y, and Z direction. So let's go ahead and look at those forces applied there. So the first thing we want to do is write down, using our equilibrium of forces in the X, Y, and Z. Okay, so in the X we got Bx plus 50 minus, and this is using the unit vector for that. And I've also substituted in this thing, calling that force CD, which you can. I'm just going to call it T for tension, because we're asked to solve for both the tension of that cable and the reactionary forces at A and B. So I'm going to call that T instead of force C D. Okay, so that works out to minus 0.1741 T. Summation of forces of Y, we got to AY plus BY plus 40 minus 0.6964. All right, and again, those are just using the unit vector divided by or multiplied by T. Okay, and as you can see, just looking at the cable, the tension, that force T has a displacement in the X direction of 1, in the Y direction of 0.5, and in the Z direction, in the X direction it only has a displacement of 0.5, in the Y direction displacement of 2, and in the Z direction it has 2. So you just take those numbers divided by the distance from C to D. Okay, and that's how you get those. All right, so that's what we get the force there. And also summation of forces in the Z direction is AZ plus BZ plus 0.6964 T. Okay, because my Y and my Z component of T are equal. All right, and that's then what we want to do is we want to find a place where you can take the moment around that gets rid of most of the unknowns. In this case, it'll be B. Because once I do that, I drop out all the forces at B because I have a moment of 0. I then have to identify the R's. Okay, that's what we're going to use to calculate the moments, because we're going to use the equation of moment is equal to R, which is the position vector crossed with the force. Okay, so if we look at the forces applied at A, it will have a position vector of 1 we put there, and it only has a position vector of 1I. We'll need a position vector for the force at C, and again it goes from the point which we're concerned about, B, to the anywhere along the line of action for that force at C. And so we'll just go from B to C, and this results in a position vector of 0.5I to J. Okay, so we're going to then do the summation of the forces at B. We're going to start with force A, so we'll do R1 cross with force A, and we set up our matrix as such, so we get that, and then we solve for that, keeping them in I, J, and K, and we get 0I minus AZJ plus AY and K. Then we're going to do R2 cross with T, and that results in 1.3928 Ti minus 0.382 Tj plus 0K. And then we also have to do and that's with the tension cable. And since the tension cable and the force have the same R2, we're going to use that. And so the force acting down will produce a moment of minus 60I plus 40J minus 80K. We'll then do a summation of the moments around in the I, or in X, and we get 0. We're just adding these numbers up. 0 plus 1.3928T minus 60. Okay, and we can then use that to solve for T, the unknown there. and we get 114.9 newtons. Then the summation of the moments around J, we get minus AZ, minus 40 plus 40, and that results in AZ is actually 0. Then we do the summation of moments of K, or in this case Z, and that's AY minus 80, and AY is equal to 80 newtons. So now we will go back to those summation of forces in the X, Y, and Z and plug in our numbers there. Okay, and this results in the X of minus 30, By of minus 40, and Bz is 0. So when we're looking at when we get negative numbers, all that means is that we go back to our original free body diagram where we assumed a certain direction. It just means they are in the opposite direction of what we assumed, but all those numbers